All right, thanks so much. Wow, it's bright up here. Let me tell you a little bit about myself and how I got involved in this project. And I'm going to walk you through a couple of the journeys that we take on this project and tell you about why Showtime and this amazing group of people decided to try and do this film. It'll come out in 2014. It's a multi-part series, and probably 8 parts. And I think it will blow the doors off the conversation around climate change. I really do. I think there's nothing even close to what this film attempts to do that has been done before, not just for climate change, but frankly, I don't think for any other topic either. In some ways, it's a huge, big, bold, scary experiment. No one knows whether things are going to succeed. You know, people don't start off to make multi-million-dollar film projects with the idea that it's going to fail. But sometimes they do for whatever reason. But what you have to do is go in there and I think give it your best shot. And I think this one has given it its best shot. And I'm excited, frankly, myself to see it. OK, so let me tell you a little bit about myself. So I was born in Sri Lanka. I was born on an island. And I was literally born a stone throw away from the Indian Ocean. That's the ocean over there. And I could see it from the balcony. And that's me. Notice the careful position of my hands there. But when I was born, my grandmother, who is the matriarch in the family, took me to an astrologer. And the astrologer read my head. They read the hair patterns on your head, like the cowlicks, instead of reading your palms. It's something that island cultures apparently do. I've heard it been done in Hawaii as well. And this astrologer read my little head and told my grandmother the news. And she comes back home and tells the family that this guy had said that I would die by drowning. Now, that's not a good thing if you live by the ocean. And my parents did what was logical. They kept me out of the sea. And so that's me trapped in this little, on this little patio. And I could see the ocean. I could go down to the ocean with all my cousins and nieces and nephews, but I was never allowed to get inside the water. And it made sense, right? So it's like the most logical thing you would do. Like if you were told you would die by drowning, what's the solution to that? Stay out of the water. That seems pretty obvious. And so that's what they did. But then when I was about 9 years old, we moved to Africa. And my mother broke with tradition. Perhaps she wasn't encumbered by family dynamics anymore. And she took a giant, courageous step with no chance or no belief that it could even be successful. And that giant step she took was she taught me how to swim. And it completely changed the outlook of my life. I haven't died yet by drowning, but I now live in Montana, which is a reason why you want to stay away from water. So, but I do things like this now on TV, and I get to do these things. I've gone diving in every ocean on the planet because of this one sort of leap of faith. And I tell you this because I think that the environmental movement is in a similar sort of moment, right? We know what's going to happen to the planet. We have a pretty decent understanding about all the challenges the planet is facing. The death of the planet has been foretold, and the question is, what do we want to do about it? This is how we want to view the natural world as scientists. It's all brown and green and looks all pretty and pastel-looking and earthy-looking. But if you map out on it all the different challenges the planet is facing, from shipping traffic to deforestation to ocean acidification to climate and on and on and on, it really kind of looks like this. This is from a paper that was published. I just pulled it right out of there. And so, the future of the planet is pretty well told. The question really comes down to, what do we want to do about it? If I went around this room and I asked all of you, you know you're going to die by drowning. Do you want to learn how to swim? The funny thing is, most of you, maybe all of you, given this audience, will probably put their hands up and say, yeah, I really want to learn how to swim. Give me a fighting chance. And that's, I think, where we are today. It's like, what do we now sort of do about it? Now, the biggest threat, the one that sort of swamps all of this map out, is obviously climate change, right? So as a wildlife biologist, this was not really on my radar screen when I went to grad school. It just started kind of being out there. Then it was someone else's problem. And then it kind of gets bigger and bigger and bigger. And you kind of get to the point where you think, Well, there isn't really anything else that I can, if there's one thing I want to do, this is the one thing I definitely want to try to make a contribution to. Right? This is the one thing I want people to understand and get and appreciate and then figure out solutions to it. Because it is dramatic. It is going to be dramatic, not because the world is going to end. The world won't end because of climate change. And chances are humans are going to be fine, and there's going to be people on the planet, and there's going to be wildlife on the planet in the future. But there's going to be massive, massive change in how we live, and where we live, and why we live. And there's going to be incredible displacements that happen. So I really worry not for the future of the planet. I really worry about the human race. And if this is the biggest problem that is coming down our way, bigger than the Cold War, then why isn't it more in our national psyche? Why aren't we arguing about it on a daily basis, right? I mean, why, if you go back and look at films, or you go back and look at 60 Minutes, or news broadcasts during the 60s, during the 50s and the 60s, the vast majority of what you would see on TV had the veneer of nuclear threat around it. Things were put in that context. You discussed issues from how much cotton was growing in the United States versus Soviet Union, to national security, to defense, in that context, because you knew that with this overriding, gigantic threat that would be cataclysmic to the planet, and every decision you made in some ways was reflected by this big, giant sun, nuclear threat. You go out today and you turn on the TV and any day and you look at what's being discussed, and things are being discussed as if there isn't this gigantic elephant in the room. It's not even an elephant. It's like a blue whale flopping around, smashing all these chairs in the room. I mean, it's really big. And it's very difficult to understand why we're not making that transition. And I don't know. I'm not suggesting one answer is better than the other. I'm just suggesting we're not having that conversation. We really aren't. So it's just been something that's really puzzled me. So I've tried to do things with climate change. I've done films before. I did something for Discovery Channel about Alaska. I did another show for Discovery Channel on energy. And they were like, meh, not so great. Kind of give it a good shot. But to be absolutely honest, I found it a little boring when I watched it later, right? And think about how many things you guys watch on TV, and think about how quickly you switch the channel off the minute someone starts droning about climate change or the end of the world, the doom and gloom. It just isn't that interesting. I mean, it just isn't. I sat next to a really intelligent, smart guy on the flight out here, completely tuned in. He goes around the world and he produces electronic dance music, and he's like really up there, one of the top people out there. He cares about the environment. We started talking about it. But it turns out that what he really wants to watch on TV are like Gold Rush. And he wants to watch something that's reality or just more interesting. It's not that he doesn't care about climate. He just isn't willing to spend the time to get educated about it, because it's dry. It's just not that interesting. And I can't help that. It's just the way it is. So I was approached. So a few years ago, I managed to get on David Letterman. And it's kind of a big deal when you go there, because as a kid, as a college student, I watched the Letterman show, and it was sort of that kind of amazing thing. And there I was. My parents were in the audience. I was petrified. There's Jack Black in the green room, lighting up, let's just put it that way. And so I go out there, and there's lights just like this. You're blinded. You can't see the audience. There's David Letterman, and he starts having a conversation with me. Now, before you go on the Letterman show, you get to talk to their producers in depth, and they ask you all these questions about what you're doing and what your life's about and where you've been. And I had these amazing adventures. I'd just crossed the Namib Desert on foot, and I'd just done the shark thing. So I had all this great material, and I was telling them, and they were all like writing it down and all that. And I could see Dave had them on the card in front of him, like on the card that he has. But he didn't ask me about any of that. He just launched into climate change. He like harangued me about it. He started asking me about this really depressive stuff, like, aren't we going down in a handbasket? What can we do about it? Why doesn't anyone care? Are you worried about this? Are you worried about that? And I really had to I had to be really fast on my feet. Now, when people watch the clip, they generally say, oh, you did great, you were fine. I wasn't. I was petrified inside, because he was hammering me about something that I should know about, but I did not feel convinced enough to talk to him about it with conviction. Like, so the number one rule is if you don't believe it yourself, don't go on stage and start talking about it. If you don't understand what you're talking about, don't try to bluff your way through audiences. I tell this to people all the time, and I was bluffing. I was doing everything I can to be sort of funny and sort of like basically finagle my way out of this trap that he had set. And it went on and on and on and on, and I got out of there and I thought, God damn it, I got to learn about this. This is something that's big. I'm a scientist. I'm a scientist for one of the world's largest environmental organizations. If I don't feel it in my bones, then how can I expect anyone else to appreciate it as well? And don't get me wrong, I'm not a climate denier, even though I have on my book here the word skeptic on it, right? So I'm skeptical about lots of things, but I'm not a denier. I understand the science. I can read it. I can intellectualize it, but I don't feel it. And that's what I wanted. So that's what I was going through, and then I was approached by these two guys, Joel Bach and David Gelber. And Joel Bach and David Gelber are veteran producers of 60 Minutes. They won Emmys. They are really well known, really well established, and 60 Minutes is one of my favorite shows because they pull it off. Every week, they pull it off. And they came and said, we're thinking of doing this multi-part series on climate change. And it's going to be big, and we don't know exactly who we'll go with, and there's all these big names associated with it, but we don't really know if they're going to sign up. They threw some names out that were interesting, like Matt Damon and Don Cheadle and Harrison Ford and big stars, Arnold Schwarzenegger. And we are interested in seeing whether you'd be interested in being one of the correspondents on the show. And my initial reaction was, I'll help you with this, but no way. No way am I going to waste my time doing something that no one's going to watch. Right? I just don't have that kind of time anymore to go around the world, do this stuff. You don't get money out of it, trust me. It's just pretty much an act of love that you do. And you just feel like, no. And they were convincing. And they showed me some sizzle stuff that they had sort of made up. And they were convincing. And then they said something to me, a couple of things to me that, so they really want to know why I was being skeptical. And I sort of said, look, first of all, it's got to be something that I want to watch. Because if it's not something I want to watch, then no one else will want to watch it. Second of all, it's got to be credible from a science point of view. And third of all, we have to be able to deliver an audience. Because if we make this show and spend all this money and spend all this time, no one watches it, then what's the point, right? So they said, well, we're going to do it in a different way to anything that's been done before. And don't get me wrong, like Inconvenient Truth, for example, really made an impact. Like my parents went and saw it, and my parents would never have gone and seen it if not for the fact that Al Gore did it and did it in a sort of a clever and different kind of way. And there was this enormous buzz created about it. So they said, well, that's great, but now we want to take it to a whole nother level. We want to engage a whole nother generation of people and really create the new gold standard for how to communicate this and how to start a national dialogue, an international dialogue about it. And we're going to do two things. The first is we're going to tell real human stories. The stories are going to be as much about the characters, the people, as it is going to be about the story. Now, that's the trick of 60 Minutes. If you watch 60 Minutes, the amazing thing about 60 Minutes, even if the story sucks, the person is always really compelling. I mean, unbelievable. They pull it off every time, right? You go watch the person. It's compelling. You might not like the story, but you'll still watch it just because there's a compelling drama going on there. And the second thing that they said that they would do was, I got to check my day, that they would focus on things that are going on right now. So climate change has this problem. It can't make the evening news because it's not newsy. It's going to happen to us somewhere down there. Now, how can you make news about that? Especially when you're not exactly sure exactly what date it's going to happen on, right? Like there's going to be a great meteor shower tonight. We know that. We can say that. But climate has this problem with it. And so they said, no, we're going to tell stories that are happening right now, not about the future. We're never going to say, this is going to happen like, we're going to talk about stories that are happening right now. And then the third thing they said, which was a bit of a sweetener for me, is saying, you can go on a journey. You can go and answer all the questions that you had when you came off the Letterman show, and you can satisfy to yourself whether this makes sense. So with those caveats, I thought this would be great. Let's sign on and let's see what we want to do. So I went on a quest. And as a scientist, these were the pieces that I really wanted to focus on, right? So the big question I wanted to ask was, is carbon dioxide. I wanted to meet these 4 scientists. They were big-name scientists. They're not the only great climate scientists. There are lots of people, and we do meet lots of others as well, but these were 4 that I really wanted to meet. And I wanted to ask them a question. Is carbon dioxide going up? And prove it to me. Can climate change abruptly? Or is it just a slow, gradual process? You know, is a disaster movie abrupt? What are climate models? Like, we always talk about these models. What the hell are models? And how do we know these models are right? Because that seemed like a really big, important question, right? Because if the models aren't right, then why should I believe what's going to happen to me 20 years from now? And these are the 4 scientists we sort of decided, well, we'll follow them and find out about them and go meet them. Now, we had one problem, obviously, and the first one is that Charles Keeling is no longer alive. So, okay, so I couldn't do that. But I could do the next best thing. So I'm going to just tell you and show you a few slides. And these are my own slides. These are not professional slides. These are literally my little snap camera snapping away for 2 of these journeys. And then we'll show you a video clip, and then I'll introduce the rest of the team, and we can have a discussion, and you can ask lots of questions. So I'll do this real fast because I just want to get through this. So is carbon dioxide going up? We went up to Mauna Loa. So Mauna Loa is a gigantic 10,000-foot volcano in the middle of the Pacific Ocean. And at the very top of it, and it's hard to get up there because you've got to go through this lava field, and you know, it's dry and hot and very cold when you get to the top. The very top of Mauna Loa, right there in the middle of the Pacific, is an instrument station. And this instrument station does one thing, and one thing really precisely. It measures carbon dioxide. And it's all the way out there because it's as far away from people as you can sort of get, far away from cities and pollution. It's sort of up in the, almost touching the upper atmosphere, so you can sniff the air that's clean and up there. And it records it precisely, continuously. Now, what's amazing about this place is that it's been doing this since 1958, continuously. Because this guy named Charles Keeling, he's a grad student at the time, figured out how to measure CO2 in the atmosphere very accurately. No one could do it before he came along. So he figured this out as a postdoc at Scripps. And he created this instrumentation, and he put up some stations, one in Antarctica, which got shut down because of lack of funding, you know, one in Big Sur, because I think he wanted to go surfing, and then he put one out in Hawaii. And the nice thing about the Hawaii one, that even when government pulled funding in the 60s, he kept funding it, like he kept cobbling money together. So it has this continual record of CO2. And guess what? When you go up there, first 2 things strike you. One, you realize that Keeling was just insane. He was meticulous. He was like a Swiss watchmaker. He was so careful about everything he did, so precise. You become completely convinced that this guy cared about exactly getting it right. And he had to haul all of that up there, like in the 50s. You get up there and you see it. And you see that record, and you see that number. Today, it's around 395.5. I just checked it this morning, parts per million. When Keeling started it, it was about 318 parts per million. And this summer, it actually went up to about 400. So what you realize is it's always going up. Now, it's going up like this. And it does that jaggedness because the Earth breathes. Most of the Earth is in the northern, most of the land mass in the northern hemisphere, and in the summers, plants are breathing, and so there's a lot of growth, so there's a change in CO2. So it fluctuates by year, but it never goes down in totality. So the parts per million right now, today, in October, will be higher than the October reading from last year. And that'll be higher than the reading before that, and the reading before that, and the reading before that. And I met a guy up there whose job it is to make sure the stuff goes on and it's all working and recording it. And he's been doing it for like 25 years. And I asked him, has it ever gone down? And he's like, no. Like every day I come out here and it's more than what it was a year ago. Every day. And you're like, why aren't you just jumping off this cliff? I mean, imagine having a more depressing job. Like every day you go up and every day the story is just a little bit worse. Just a little bit worse. And that was his story. It was amazing because once you come off that mountain, you're like, yeah, it's happening. What's also cool is they gave me a little bit of air from the mountain. They locked it up in a little vial. They wrote it down. By the time now, a year later, it's gone up. It's gone up by like at least a couple of parts per million. So it's at 395 now, and it continues to go up. OK, second journey, can climate change abruptly? So to find this, I went with this guy named Paul Majewski. And Paul Majewski is literally the Indiana Jones of climate change. He goes to the ends of the earth. He does crazy stuff. I mean, like, he's explored Antarctica. He's explored Himalayas. He's gone all over the world. I mean, really, really hardcore expeditions. And here we are getting ready to go up to a gigantic mountain in Chile, on the border between Chile and Argentina. And when they told me that we're going to go up there, I looked at all this research stuff, and it said 5,000. And I thought 5,000 feet. It's 5,000 meters, and that's the base camp, right? So we were going to go up to about 20,000 feet, and that's a long way to get up. And we were going to go up fast, and I don't like going up that high. I'm from an island, for God's sake, right? So what Majewski does is he goes up to these really remote, big chunks of ice that are stable and old, and he drills them. He brings the ice core up, and he does something very cool with that ice core, and I'll tell you about it in a second. So I'll just go through a couple of slides of what it's like to do an expedition with him. So this is us like in the middle of this Chilean Andes, and that's how you cross the rivers, right? It's just a leap of faith like that. But notice everyone taking photos. Like there's no one with a rope or no one like giving the guy a hand. It's like, jump, we're going to take photos. This will be great. And that's what this team was like. It was absolutely, I honestly thought I would die here. I really honestly thought I would die. I wouldn't die by drowning. I would just die because a rock about that big would fall on my head and kill me. And you can just see a little bit of the mountain that we're going to go up to the top there, that little bit of ice. That's us at the base camp, kind of getting ready to make the final push to the top. Basically what we're going to do is get to the top, which is an old volcano, and then we're going to descend into it, and there's a giant, thick glacier inside it. And that's a really stable, thick glacier that he can drill. And the further down he goes, of course, the older those ice records are, right? And so by studying them, he can tell you a lot about what it used to be like back in the day. We had helicopters, but these helicopters were great. They wouldn't actually take us anywhere. They'd just fly over us and film us. And so we had to slog our way up these mountains. And it's hard to fly a helicopter at 18,000, 19,000 feet. So we didn't walk the entire way up there, which might sound great, but it's actually much, much more risky because we actually had to go up on horseback and mules. And let me tell you, first of all, these things are really small. And second of all, they don't have the Western saddles that I'm used to. They have sort of a Argentinian, Chilean saddle. And third of all, I mean, it's petrifying going up with a horse up there. Just to put this in perspective, there's these big sulfur lakes up there as you get up high, which is just absolutely gorgeous. And that's what the terrain starts looking like, right? And notice, so the couple of people who was with me, one of the producers and the AP on the show, they took riding lessons in Central Park. It's absolutely true. They took riding lessons in Central Park. It's like nothing prepares you for this. And let's see if I can show you a little video clip. This video clip is not from the film. The film looks great. This is my rubbish clip from my little camera, okay? But it just sort of, and you can tell that I can't even speak right. I'm getting all the names wrong. Because by the time I got to the top, my oxygen saturation level, right now yours is about 99% or to 100. Up there, for me, was 78. And I was one of the stronger ones up there. So you're not thinking right. Let's see if this clip goes.
I am up here on Tupangatito, probably at...
Maybe not. Wow, technical difficulties. Oh, that's really bad now. And then I died, and that was it. And that's what I saw. So there is life after that. Wow, Microsoft PowerPoint could unexpectedly ignore. Does someone who thinks they might know want to just give it a try? If it doesn't work, we'll go forward with it. But that's quite amazing. It's a heavy clip, but we did download it onto the thing. Right, so let me tell you what happens when you get up to the top. So you make your way up on these horses to near the lip of the glacier. Then you get off the horses, and then you hike your way out onto this big ice sheet. And you're tied down with strings, and the cameraman is like puking and all this. Of the 12 people who set off going, 4 people didn't complete, so only 8 people got to the top. Our cameraman almost died and had to be evacuated out of there. We got a second cameraman who fell off a horse and hit his head and was unconscious for a while and not feeling too good. And so a third person, who's sort of a backup cameraman, was filming a lot of it. The most experienced person on the journey, which are these local arrieros, these local cowboys who were taking us up there, was thrown off a horse and broke his shoulder. So this is sort of what happened. So when you get up there, Majewski then starts to actually go to work. So he and his team gather and they drill into the ice. They drill this deep, deep ice core, and they pull up this perfect tube of ice, which they hold with gloves, and they stand upwind, and they're all wearing like white suits so they're not contaminating it at all. And then they put it into a tube and keep it cold, and then they get it back to their lab in Maine. And what happens in Maine is, see if you can run the video. If it runs, then great. Otherwise, we'll just flick through it and go to the next one. So what happens in Maine is they then go and try to figure out.
I am up here on Tupungatito, probably at 19,000 feet, maybe a little bit more, heading to the very crest of the volcano. And I'm here with Paul Majewski. Paul, am I saying that right? And Paul is a glaciologist and climate scientist, and he goes to the ends of the earth to look for big, fat glaciers, which unfortunately means dragging all of us up this insane, insane, insane terrain. Once we get there, the real work begins, and I can barely breathe. And out there to the left, the tallest peak in all of the Americas, actually the tallest peak outside of Asia.
I mean, this is this guy's laboratory. It sort of just tells you what sort of extreme lengths these climate scientists go to get their data.
Aconcagua. And here's Tupungato. And here, oh, just a few meters away, is the lip of Tupungatito, which is what we're climbing. And that's me.
All right, so we get up there, and that's the crew like filming. Now, they don't get on the ice sheet because the ice sheet can break and there's just giant crevasses. But they send me out there because I'm expendable. So I'm roped to Paul, and Paul drags me out there about half a kilometer away. And then once we get there, we basically start doing the work. So what does he get out of this ice? That's Paul over there. So what Paul does is Paul takes this ice, and what he does is amazing. When he gets back to Maine, he can tell you over 100 different things that were going on at any point in time going back now up to 200,000 years with these giant cores that he has from Greenland. It's not temperature that he's interested in. He's interested in abrupt changes in climate. So he looks at wind. So it turns out that where the wind blows from makes a big difference. So he can tell you things like ocean productivity. Ocean productivity in the Pacific. He can tell you that from a glacier in the Andes. He can tell you how much dust there was in the atmosphere. He can tell you how much rainfall there was in the atmosphere. He can tell you all these things over 100 different parameters. And he can do that by basically examining the ice and looking at it from a chemical perspective about what's trapped in the ice at any particular time. It's like tree rings. They core it down. The further down you go, the older it is. And then it can give you this precise measurement of what's going on out there. Now, what's cool about what Paul's work does is that Paul says climate can change abruptly. And when I say abrupt, he means like disaster movie abrupt, within 10 years. So he says, take Mesopotamia, big civilization out in present-day Iraq, and it swapped in about 10 years. It went from fertile to really, really bad because the winds shifted. And the wind shift changes immediately the rainfall patterns, which immediately changes how arid or how dry or what they could farm or they couldn't farm. So Paul says right now, climate change is happening, and not only that, there are abrupt climate change events that are happening right now, for example, in the Arctic. So, quick journey about what he does. Paul goes back to 200,000 years, and he really looks at weather, climate patterns and how quickly those climate patterns can change. All right. The next journey is, after that little adventure, I'm like, I'm only going someplace tropical, and it's got to be nice. So they sent me to Christmas Island, right? Christmas Island is a tiny speck. It's the biggest atoll on the planet. It's right on the equator. It's about 1,000 miles dead south of Hawaii. And it is kind of interesting because there's corals there. And so here's our film crew out there. And I was with her, Kim Cobb, who's a scientist from Georgia Tech. And Kim looks at coral, and she studies how coral grows under different climate, under different temperature conditions. So it turns out that we have instrumentation to measure temperature of the ocean. The ocean temperature makes a big difference because the ocean traps so much heat. How the ocean changes makes a difference to us. One place that we don't have good instrumentation for is in the tropical Pacific. Guess why? We haven't been putting thermometers in the water there for very long, right? Only really since World War II where we started to take that kind of data, and it's not even that great, that kind of data out there. We just don't have thermometers in the middle of the Pacific. So what Kim does is she looks at coral, and if she drills into the coral and takes a core out, what she can tell you is exactly what the temperature of the water was at a particular date. Like very accurate. Like she can tell you in November of 1971, the water temperature was this. And she can do that because coral grows in response to temperature. So there are two isotopes of oxygen, C16 and oxygen 16 and oxygen 18. And the way those get assimilated into coral skeletons is dependent on temperature. So by working out the ratio of these two isotopes, Kim can tell you very precisely how that coral was growing. It's kind of a cool trick that she has. So we go down there. Oh, there's lots of cool animals, too. So Christmas Island is just like wildlife paradise because nothing's really afraid of humans. So you can get really close to frigate birds in this case while we're all waiting for them to be done. Or tropic birds, which are really a cool bird. And Kim and I are looking at these. But, all right, that's the water like. It's very different from what we did in Chile, obviously. And this is the underwater drill that she has to use, that she's sort of testing it. And I don't have the underwater drill clip, but I can show you, if this works, I might bomb it, what that drill looks like on land. And we're testing it on a piece of coral. The drill didn't work, by the way, when we first got there. All right, so you can see, just sort of drills through a piece of coral. But now, we then take that and go, please don't. OK. And then we go underwater, and we do the same. And it's complicated and difficult, and there's lots of tubes around the water, and you think you're going to die. And I remembered what my grandmother said, and so that's always going through my mind. But it's pretty neat, because she just drills into this coral, big coral head, goes straight down into it, and then she pulls out a core, and a piece of core I'm actually holding in my hand right now. And it comes out in chunks, and so she keeps all those chunks together. And she can use that to go back as long as that coral was alive. So she can go back a couple of 100 years with that kind of data. Now, this piece in particular was kind of amazing. We can talk underwater because we have the kind of headset that we can communicate with one another. But she actually was saying to me, you can see the 1997 El Nino event right now just by looking at that core. And sure enough, when 1997 El Nino happened in the Pacific and the Pacific really warmed up and all the corals essentially stopped growing, you can actually see it on that white piece of coral. It's like a line. It's like a band. And it was amazing to me to see that moment where you see, like, you don't need like more science than that. You're seeing it. And you can see how ocean temperature was affecting that coral in this very specific way. Kim has another trick. And that is, now she can only go up to a couple of 100 years in terms of knowing what the temperature was because the corals don't live that long, right? So even a big coral head is only a couple of 100 years old. But she has another trick to figure out how to go back further, like thousands of years. And that's by picking up fossil coral pieces on the beach. So it turns out Christmas Island collects all this huge amount of coral that's become fossilized and chucked up on the beach by storms. So Kim picks up these pieces, right? and drills them just little bits. But by getting enough of those pieces, she can then start constructing chunks of climate record that go back 10 years at a time, 10 years, 30 years, 50 years, 20 years, 10 years. And she can string it all together and get a coral record that goes back like 7,000 years. And that's a pretty neat trick that she has, because she can take those chunks of coral, she can date them, and then she can go in and basically tell you what the temperature was like. And that's a cool trick that she sort of figured out, and she made her career doing this. So what's neat about Kim's work is Kim's work can tell us what the temperature of the ocean was very accurately going back 7,000 years, and month by month by month, maybe even by date, I mean, but literally month by month, right? So how does this all fit into what's going to happen in the future? And that's where the models come in. And I don't have any video or anything like that, because I just went and met Michael Mann, you know, the hockey stick fame guy, who's like one of the fathers of, you know, modeling and climatology. And I met him in Vegas, which is a great place to meet Michael Mann, because Vegas is like, you know, that's the gamble. That's the toss of the dice that you're playing right now with the planet's future, right? And we're doing odds that no one in Vegas would ever take. And here's the way what Mann's work does. Here's the way these models work in order to tell us what the future is. Because Kim and other scientists are very good at telling us what the temperature was in the past, very specifically, very specific dates, you can take a model, and a model is just a, you know, a model is just a simple way of combining different factors to make a prediction. And you can run it backwards. And if you run the model backwards and it meets all the temperatures that you know the planet was actually experiencing going back 50 years, 100 years, 1,000 years, then you have confidence that if you run the model forward, it's going to make sense. Get what I mean? And that was like a big revelation to me, because I never understood how you could create a model, most of it's a simulation model in the computer, and then believe it, and believe what it's going to tell you 50 years down the road. But the way you do it is by people like Kim providing data that tell us what the temperature was, what the weather was, what the temperature was, what the climate was, with Majewski's work in the past. In Majewski's term, rainfall, in Kim's term, temperature. You can run the model back, and if it meets those numbers, then you know that going forward, it's probably also going to hold true. And so that was basically my journey, this great trip around the world to lots of different places to meet lots of different scientists and to give them a voice and really understand their work and to sort of feel it in my bones. Now, I want to show you a film clip of what the whole is a sort of a trailer. And but before I do that, I'll just mention one thing to you. So one of the things I realized with scientists is when you talk to them, they put on a veneer. They go into science speak. And that was a real challenge on film. But what you hopefully will get when you actually watch the series is, at least for the people I met, you'll really understand who they are as people. So we didn't just meet them in the lab or in the field, but we even went to their homes. And you really get the sense that these are people who are extraordinarily dedicated, extraordinarily meticulous. And you hopefully form an empathy or a bond with them, because by believing in them, I think it helps the audience then believe the results of their work, which I personally found pretty impeccable. So Maggie O'Brien and Tommy Armour, who are both with the Years Project, and they're here at the conference as well. So if you have questions about what this program is about and so on and so forth, you should talk to them. But basically, 8-part series on Showtime, got a great cast of characters from Arnold Schwarzenegger to Jessica Alba to Harrison Ford, Don Cheadle, and journalists like Leslie Stahl, Tom Friedman, Chris Hayes, and others, and dynamic storytelling about what climate is going to do, what's happening today, what the science is, and hopefully it'll blow your socks off. And we need all your help to get the word out, because we obviously want people at least giving it a shot and watching it. So do you want to play a trailer? So this trailer has never been seen before. I haven't even seen the trailer before. If you blink, you might miss me in it, but I'm somewhere in there. The next film we're going to make is about seamlessly making presentations work. It's going to be like a huge film. Millions will be spent on it. Ha.
99 scientists out of 100 say climate change is real and it's only going to get worse. So if you were sick and you got 100 doctors and 99 of them said you had to have an operation, would you get another opinion? I don't think so.
Our world is changing faster and more dramatically than ever before.
Not true. Global warming ended in 1998. I'll show you the data for it.
There's so many political agendas, there's been so many exaggerations that it's brought a lot of confusion.
Ice melt, rising sea levels.
There is no more fire season. We have wildfires all year round.
Why do you think Republicans have gotten in this spot of distrusting the scientists?
Methane coming out of pipes all over the country. That's a big deal.
At what point does this become the priority?
Fire commencing.
Everybody thinks that this is about melting glaciers and polar bears. I think it's a big mistake. This is 100% of people's story. So I've teamed up with the legendary Jerry Weintraub.
So hurricanes are twice as bad as they ever were, and ice is melting where it's not supposed to melt.
This is a lake?
Yes.
The world is changing, and it's all because of global warming, I think.
Jerry and I are putting together the ultimate cast. You'll see these stars like you've never seen them before. They're going to be the correspondents, meeting the people affected by this. These are the stories of people whose lives have been transformed by climate change.
We used to have seasons back then.
Right.
Now we don't.
Could Yemen run out of water?
Yes, possibly.
This was the first city to run out of water.
Water just took everything away.
Climate disruption is not a political issue, it's a moral issue.
I don't know what causes it. It doesn't matter. It's happening.
This is the biggest story of our time. And this is the time to tell it.
Nothing could have prepared us for what we saw.
Great. So, thank you. Questions, discussions, ideas, thoughts? Season 2? Yeah. Go for it. Yeah, so I'll just repeat that. So my segment focused on science and the scientists, but what about values as the discussion moved to a different stage? You're right, and that's why you have all those other correspondents. So Don Cheadle goes and talks to ranchers in Texas. And Harrison Ford goes and talks to loggers in Indonesia. I got the science beat because I'm a scientist by training, and it sort of made sense. I think you need the science bit, but I don't necessarily think it'll be the driver of why people will ultimately care. You do want to make sure there's a nail in that one and that there's no sort of dispute there as best as I can. But you're absolutely right. Sorry, I go here. Do you want to, how hard is the fossil fuel industry and the role of politics confronted in this? I think it's a challenge, though, because you ultimately want to make a show that's broadly appealing to people, that you won't just completely turn off simply because you think that's already bias coming to you. But it is challenging to do it because, unfortunately, you know, probably since Nixon, you know, the environment has become labeled with an agenda, with sort of a left agenda, which isn't necessarily fair to all the Republicans who do care about the environment. And it isn't fair to the Democrats who think that this is something that they own. It isn't. It should be genuine debate that's been held by all parties. Maybe you could disagree about how to do something about it. But the fact that it's happening or the fact that it's an issue should not be something that's a debate. So we did try in this not to go down one political track, but it is tricky. And then we reached out to the evangelical community. You know, one of our stories is about, you know, the daughter of an evangelical preacher, right? Yeah. Yes, sir.
Part of that last discussion is the cost of doing something versus the cost of doing nothing. But to me, the bigger concern, we hear about polar bears, and you see the seaside parks, a roller coaster in the water. That's really the tiniest bit of the story to me. And I don't ever hear about insects, the role of the pine bark beetle in Colorado killing the pine forests, which caused the enormous fires, which caused the enormous mudslides, which killed lots of people. I don't hear about bacteria and viruses and the spread of you know, dengue fever, valley fever, all kinds of pandemic potential. To me, that's the big threat to the human population. Yes, Rex Tillerson, the CEO of Exxon, calls it an engineering problem. Sure, we can move away from the water, but you can't move away from the pandemic.
Sure. So you'd be happy to know we do make an effort in this. Pine bark beetle is part of the story. It was filmed out in Montana. I haven't seen what the final cuts look like, but it's there. Disease and climate change was really part of the mix of discussing this. So your point is well taken. Again, you're trying to connect with as many people as possible and trying to be as compelling as possible. But they were both in discussion and in the mix when we started to do this.
So Arnold Schwarzenegger is doing an episode in Montana about fires and more wildfires, and we do definitely take a look at the bark beetle and how that's really causing problems with deforestation inside the U.S. So, yeah. And also, Matt Damon is doing an episode about heat waves and how that's really causing a lot of problems, you know, health problems.
Yeah. Go there and then come back to you. Yeah. Certainly in my journey, the real distinction between weather and climate, we hit that hard with every scientist we talked about. And I think the best, the two that really were convincing to me, so Majewski does really look at rainfall. And you know, he was pretty convincing how quickly rainfall patterns can shift within like the period of a decade. And you can see those shifts in the history of the planet. And so his clear warning was, this happens really rapidly. You'll see large changes in weather that are driven by climate. Absolutely, you can't pin any one on it. But that's like, you know, it's a very strange sort of way of trying to say that it doesn't really happen. You can't pin any one on it, but the preponderance of evidence suggests that they are, you're changing the probabilities that they're going to happen really, really dramatically. I'll have to come up with a clever way of putting that out there. But we do talk about weather and climate, the difference, and how much attribution we can make to weather events. Carrie.
Thank you so much for doing this. It's such an important breakthrough in storytelling that I can't wait to watch it. So one of the things that people criticize the Inconvenient Truth for is that it laid out a number of problems, but it didn't engage people in solutions. So how have you all been able to sort of both tell the stories and engage from a compelling standpoint, the human factor, but also give people ways to respond and act?
Good point. So I am not convinced that the reason why people aren't doing something about climate change today is because we don't have solutions. I just don't buy that, because that's just, it's almost like it's a cop-out, right? So it's a bit of a cop-out because, in honesty, most of the technology we need to make a difference is already here. It'll get cheaper if we'll put more money into investing in it. And a lot of the solutions are right in our grasp. It's just a matter of economics, political will, and getting enough people to adopt it, right? So that suite of solutions, a lot of the solutions, not all of them, but many of the solutions currently exist. It's true Inconvenient Truth doesn't delve too much into solutions. And in this series, we do talk about solutions, but there was a real thoughtful decision made that we wanted to tell human stories. We wanted to get to the audience so that no one out there in America would think that climate change wasn't happening, and B, that it wasn't happening now. And I know that sounds hard for all of you to believe, or many of you to believe, because you're here and you're self-selected. But if you go out there in the real world, this is not what people are talking about. And it's not because we don't have a solution to Syria. We're sure talking about it. We don't have a solution to education. We talk about it. We don't have a solution really to obesity, but we talk about it a lot. We have solutions to climate change, and we're not talking about it. And so the first thing we want to do is 8 parts, blow the audience up, get them to really talk about it. And ideally, a second season that would focus on the solutions. And there isn't one solution. There are a whole spectrum of solutions, and that's where the challenge is going to be. I'll take one more, and then we take one more? Yes, sir. All right. Talk to you.
So I'm Kevin Wilden from Sustainable Surf, and I'm a geologist. I actually studied in Antarctica, and I met Paul Mayuski in the dry valleys of Antarctica.
Oh, wow.
About 20 years ago.
Did he try to kill you as well?
No, he did not. But I'm excited to see your film. This is one of the key things that we need in climate change. I mean, there's basically 2 things missing. It's a lack of credibility and a lack of direct personal connection to the solutions. And so you're making the earth scientists seem like the rock stars, and they should be. And I think that's going to help change the whole dynamic of the debate. So I'm very, very thrilled to see that. Thank you.
Great, thank you.
But when it comes to the solutions, people have to engage directly to them. So you hear about these big problems, and I'd venture to say that most people here haven't done their carbon footprint and maybe don't even know how to really reduce it significantly beyond maybe just a 10% or so. So that's where we need to really focus on actual action, is having engaging solutions that people can follow. So I hope you get your second season. That'll be great.
Thank you. Thank you so much. And those guys are, Mayuski, Cobb, man, they really are rock stars. And when you see them in life and then you'll see them on screen, I think you guys will agree. They'll hold up with Schwarzenegger. Thank you so much.